Okay, here we go. Just gonna blast through some of these. This is courtesy of Gavin here. Okay, so I guess we're doing 3 through 60, but every third one. So it sounded a bit daunting at first, but I guess it's not so bad when we're dividing everything by 3. So we're asked to determine whether each sequence is arithmetic, and just write yes or no. Okay, so let's do number 3. Okay, so we'll just call this a sub n. And by the way, you can have your choice of letters here. Sometimes you'll see n. Most of the time you'll see n. Occasionally you'll see I, and then less occasionally you'll see k. But you could choose any number you want. And then if we were doing another series to compare, it'd be like b sub n and then c sub n, etc. So a sub n I'll use, but that's not written in stone either. This could be any letter you want. I just chose a sub n. Okay, so it's a sub n equals, let's see, for number 3 we have 1, 2, 4, 8, 16. So 1, 2, 4, 8, 16. Okay, so we're asked to see if this series is arithmetic. Okay, well, so we're looking at differences here. So we have to add 1 here. So plus 1. Oh, and right off the bat, we're adding 2. So plus 2. These differences are not the same. So this is not arithmetic. In fact, this looks like it's geometric, right? So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8, etc. So this is actually a geometric sequence, not an arithmetic. So number 3 would be no, it is not arithmetic. Okay, so go to number 6. Find the next 4 terms. Okay, number 6. Guess I could have just gone straight down to 6. Find the next 4 terms in each arithmetic sequence, then graph the. Oh, if I were graphing. Okay, so it's 6. So 15, 6, negative 3. So I got a sub n equals 15, comma 6, comma negative 3. So if I was to find the next 4 terms, let's figure out what our differences are here, and then just kind of keep the pattern going, right? So 15, the difference between 15 and 6, we're going to be subtracting 9, and then we'll subtract another 9. Okay, so we're just going to keep that pattern going 4 times in a row. So negative 3 minus 9 is negative 12. Negative 12 minus 9 is negative 21. Negative 21 minus 9 is negative 30. Is that 4? No, it's 3. And so negative 30 minus 9 is negative 39. We're asked to graph it. Well, all we're doing here is, let's write this over here. We're just connecting the dots, we're drawing the dots, right? So we've got, actually probably have to do this. Okay, so our first term, a sub 1 is 15, and then a sub 2 is 6, a sub 3 is negative 3, etc. So this is going to be our a sub values, so a sub n over here, and then this is going to be our output. So let's call it output O. Or you can think of this as x and y, either way. And we're just plotting points, right? So a sub 1, so at the point 1, we're at 15. Let's scale this. So you're going to negative 39, so we'll go like maybe 10 at a time. So there's 10, 20, 30, negative 10, negative 20, negative 30, negative 40, etc. Right? So a sub 1 is 15, so right about there. A sub 2 is 6, so there's a sub 2, it's going to be about 6. A sub 3 is negative 3, so right about, yikes, there, okay. A sub 4 is negative 12. So we're just kind of plotting points. This is pretty simple stuff, right? So we go on and then it's, let's see, 3, 4, 5, 6, 7. So a sub 7, 4, 5, 6, 7 is negative 39. So we're just kind of drawing this. We're not connecting the dots, right? This isn't a function so much as it is a sequence. So we're just plotting points here. No big deal. All right. That's 6. We're going to do number 9. Number 9. Financial literacy. Okay, so Kelly is saving her money to buy a car. She has $250, and the page is cut off. So she's saving $75 a week from her job as a waitress. Okay, how much will Kelly have saved after 8 weeks? Okay, so we can write this as a function, but we're dealing with sequences in series, so let's just deal with sequences, right? So a sub n is number 9. So a sub n. Okay, let's write a couple of terms and see if we can define this. So let's see. She has 250, and then $75 per week. So a sub 1. After 1 week, she had a 250 plus 75, which is 325. That's a sub 1. And this is one of those cases where it might make sense to write a sub 0 right? So after 0, and in fact, let's do that. Let's do that. So A sub 0, after 0 weeks, she has $250. After 1 week, she has $325. We've added 75, right? After 2 weeks, A sub 2, we're going to add another 75, so we're going to be at 400. Okay, so we're starting to kind of see a pattern here. We're starting at 250, and we're adding 75 each time. Adding 75. 75, not 25. Okay, so this is an arithmetic series because we're adding 75. We have a common difference between our terms, and we're starting at 250. We're not starting at 0. All right, so we're asked to find how much she'll have after 8 weeks. Okay, so we're asked to find A sub 8. Well, let's see if we can think of a formula that matches this pattern here, right? So we're starting. Our initial condition is 250, and essentially, if you think of this term in terms of functions, our slope, if you will, is 75. So for every one that the value of 1 that we increase A, we're increasing our output by 75. So really, it's going to be 75 times n. And we're starting at 250, right? So plus 250. So after 0, A sub 0 is just going to be 250. A sub 1 is going to be 250 plus 75. We add 75 once. A sub 2 is going to be 250 plus 75 times 2, because we've added 75 twice, etc. Right? That's just actually A sub n. And then we're asked to find A sub 8. That's going to be after 8 weeks. So let's just do the math. It's going to be 75 times 8 plus 250. And what's 75 times 8? I don't feel like doing it in my head. It's too late. So go 75 times 8 is 600. Plus 250 is $850. So she'd have $850 after she's done waiting tables. Oh, wait, it would be. If the car costs $2,000, how long will it take her to save enough money? Well, okay, we just plug in. We don't need an A sub at all there. It'd just be 75n plus 250. I want to find, okay, so 75n plus 250 equals, and we're going to equal 2,000, and just solve for n, right? So we 75n equals, let's see, 2,000 minus 250 is 1,750, and 1,750 divided by 75 is that right? 23.333. So it's actually going to take her 20. Remember, this is discrete, so we can't have decimals here. It's just going to be n would equal 24 weeks. So after her paycheck on the 24th week, she'll have the $2,000 that she needs to buy her dream car. All right, let's see, we just did number 9, so 9 plus 3, as I'm told, is 12. Never trust my arithmetic, but I believe that's true. Let's see, 12. Let's see, which one's that? Determine whether each sequence is geometric, right? Yes or no? Okay, so we've got A sub n. Actually, let's mix it up. Let's call this A sub I equals, let's see, we got 27,931. So 27,931, etc. Okay, so remember, we're talking about geometric, not arithmetic, so we need to figure out ratios here, what we're multiplying this number by to get this number. So what are we multiplying to get our next term? Well, 27 divided by 3 is 9, so we're actually multiplying by 1/3 here. 9 divided by 3 is 3, so we're actually multiplying by 1/3 here as well. And, of course, 3 times 1/3 is 1, so yes, looks like our common ratio here is 1/3, because we multiply by 1/3 to get to each next term. So yes, this is, in fact, a geometric series, because we have to multiply each term by the same number to get the next term. And sure enough, if you took 27 times 3, 27 times 3 is in fact 81. Square root of 81 is 9. 9 times 1 is 9. Square root of 9 is 3, etc. So that checks out as far as the geometric mean test as well. Okay, number 15, where are we at? Find the next 3 terms of each geometric series, then graph. Okay, so 15, let's call this one, let's just go A sub k, just to be fun. A sub k equals, where are we at? 15. 8, 16, 32, 64. So 8, 16, 32, 64, etc. No, it's not going etc. We're actually going to write the terms. Okay, so let's check and see if this is arithmetic. Looking for the differences here. 8 plus 8 is 16, so there's a difference of 8 here. 16 plus 8 is not 32, so this is not arithmetic. Now let's check and see if it's geometric. Well, 8 times 2 is 16, and 16 times 2 is 32, and 32 times 2 is 64. So it looks like we're dealing with the geometric series. Let's just continue the pattern. Find the next three terms. Okay, so 64 times 2 is 128. 128 times 2 is 256, and 256 times 2 is 512. And I hope you get the idea of graphing this. You're just gonna, draw your graph, and here's your a subs right here, and you'd probably do a scaling of about maybe 50 or so just to kind of draw the points, etc. So it's gonna end up looking kind of exponential-ish, something like that, right? But I won't draw the entire graph. I'll leave you to plot those points and spend your time doing that. Okay, so let's see, 18. Determine whether each sequence is arithmetic, geometric, or neither. Explain your reasoning. Let's see, we got 5, 1, 7, 3, 9. So A sub, we'll call this B. Sequence B sub, I don't know, B sub Q equals, okay, so we got 5, 1, 7, 3, 9. 5, 1, 7, 3, 9. Okay, so to check and see if it's arithmetic, let's look at this difference here. We're going to subtract 4. So we should be able to subtract 4 and get to 7 if this is arithmetic, and that's not true. So this is not arithmetic. Now let's check and see if it's geometric. We should be able to multiply by the same number. So let's see. 5 times what equals 1? Well, 5 times 1/5 equals 1. And 1 times 1/5 does not equal 7. So right off the bat, we know that it's neither arithmetic or geometric. So it's neither. Booyah. Okay, how much time do we have? Okay, let's do a couple more. Okay, so we're up to 21. Oh, that's on the next page. Let's close that 1 second. Let's see here. Oh, here we go. Okay. Determine whether each sequence is arithmetic. Right, yes or no? Okay. So 21. We'll call this A sub. Let's go back to A sub n. That's fun. Let's see. We got 1/2, 1/3, 1/4, 1/5. 1/2, 1/3, 1/4, 1/5. This is an interesting. This is a series. We're adding these together. It's called a harmonic series, actually, and you'll be interested to know that it does not converge. You'll find that in Calculus 2. Okay, so we're checking to see if it is arithmetic. Now, it's tempting to go, well, let's see, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. Hey, good. Now, you have to be a little bit careful with fractions, right? So let's take a look at the difference between these two numbers. 1/2 minus what equals 1/3? Well, 1/2 is the same as, let's find a common denominator. 3 times 2 is 6. So this is 3/6. And this is 2/6. So the difference is 1/6. Now, how many sixths is this? Well, it's not really an even number of sixes, so let's find a common denominator here. So how many twelfths is this? This would be 4 twelfths, and this would be 3 twelfths. So the difference here is -1 twelfths. So that's not actually going to be the same difference there. So this is not an arithmetic series. No. All right, number 24. Number 24. We'll call this A sub I, arbitrarily. And let's see, we got 2/9, 5/9, 8/9, and 11/9. Okay, so we're checking to see if it's arithmetic, so we're looking at differences here. So to get from 2 ninths to 5 ninths, we're going to have to add 3 ninths, or 1/3 if you will. And to get from 5 ninths to 8 ninths, we're also going to add 3 ninths. So it's looking good so far. And sure enough, we're going to add 3 ninths to get from 11 ninths, or sorry, 8 ninths to 11 ninths, plus 3 ninths. So yes, that is arithmetic, because there is a we add the same thing to get to each subsequent term. All right, let's go to 27. Where we at? Find the next 4 terms in each arithmetic sequence and then graph your sequence. Ugh, graphing. Using up so much paper. Let's just, I'm just going to assume that you're okay with graphing, and we'll skip that for now. Let's do 27. Let's call this one B sub M for no reason at all. All right, number 27. We got -5, -11, -5, -11, -17, -23, -17, -23, and we're finding the next next 4 terms. Okay, so let's find our common difference here. If we're told that this is arithmetic, we don't have to find all of them. We know they're all the same, right? So -5 plus what is -11? -5 plus -6 is -11. And sure enough, -17 plus -6 is -23, etc. So we're just going to basically subtract 6 each time, right? So the next term is going to be -23 minus 6 will be -29. -29 minus 6 would be -35. -35 minus 6 is going to be -41. Is that enough? Maybe we need one more. That's a lousy 41. So -41 minus 6 will be -47. And there you go. There's number 27. Actually, I think, let me check that out. Yeah, I think I'm going to stop this for now and reset. I'll pick up at number 30 on the next video.